So Katie Mika, she is a data services librarian at the Harvard Library and IQSS, and she advocates for enriching computational literacy, data stewardship, and open science for students, researchers, and librarians across disciplines. And she's also my collaborator, so thank you so much for joining today. And yeah, the floor is yours. Take it away.
Hi, thank you very much for the introduction, Anna. I'm gonna share my screen. Give me a second to get it all set up the way I want it. Can you see it okay? Okay, great. Okay, so hi, again, I'm Katie Mika. I'm a data services librarian. As Anna said, I work at Harvard Library and at the Institute for Quantitative Social Science with the Dataverse and Harvard Dataverse teams. So today I'm going to talk a little bit about some results from a project that I am still working on, but started a few years ago, that included interviews with civil and environmental engineering graduate students about research data management habits and attitudes. So this project is a collaboration between librarians at CU Boulder and Carnegie Mellon University, and also me, although again, this work started while I was still working at CU Boulder. So all of the students that I'm speaking about are going to be, we're in civil and environmental engineering graduate programs at CU Boulder and Carnegie Mellon. So the idea for this project came out of a bigger previous large-scale mixed methods research project that examined research habits of civil and environmental engineers more generally. It found that researchers usually lack or often lack really comprehensive or systematic strategies for data management. I love this quote from it. I think it really captures a lot of our feelings about data management sometimes. But from here, we thought it would be interesting to see if kind of the next generation of civil and environmental engineers are currently learning any data management skills that they might be carrying forward into their careers. If they are, so we can avoid some of those, big problems of not being great data managers on some big grants in the future. And so if they are learning about these kinds of activities, how are they learning it? Who are they learning it from? What are some successful models? How can we replicate those in different institutions and in different disciplines? If they're not, what are some of the pain points in particular, and where can we address some of these gaps? And then finally, are there specific disciplinary practices within civil and environmental engineering, particularly that affect RDM? And can we kind of consider that in developing programming to reach these and other communities in the future? So to answer these questions, we developed kind of a semi-structured interview protocol that asked graduate students some of these questions. The interview largely followed this research data lifecycle, where we asked about, at the planning stage, what are your plans for managing your data? Especially, what do you plan to do with your data when you graduate? That always got us some interesting answers. In the collection phase, we wanted to know, are students typically producing their own data? Are they collecting their own data? Are they inheriting data from a lab or from an older graduate student or from their PI? Or are they going out and sort of hunting down data in the wild, so to speak? And then in general, sort of regardless of how they collected it, what is a typical size of the data that they're working with? We also asked what type of data they were working with and what tools they used to work with that data. We asked how they analyzed it, how do they back up their data, if they back up their data, and whether or not they're using version control. With regards to sharing in particular, how are they sharing data with collaborators? Do they publish their data? And if they are publishing their data, what parts of their data are they publishing? What do they consider a publishable unit? And then specifically for reuse, are they doing anything specific to prepare data for others to use? So we aimed for a somewhat representative sample of students. We interviewed 19 students total, 9 from CU Boulder and 10 from Carnegie Mellon. We limited according to lab or advisor so that specific labs weren't overrepresented. We interviewed both master's and PhD students, and this slide kind of shows the distribution of where they were in their degree programs, how far through they were. About half of students worked with big data, at least in some way that they would describe that. We let them kind of define it however they wanted. If they asked, we gave kind of a general window of about 1 terabyte as kind of a cutoff. Things smaller than that as small data, things bigger than that as big data. Students are also using a variety of methods in their research. So mostly modeling, obviously, as engineers, but they're also incorporating some other methods and some interdisciplinary methods too, which is interesting. So interesting things that we found out. So when students did discuss data sharing, again, this project, the interview kind of covered the entire data lifecycle. So we're not just looking at data sharing and reproducibility specifically. We were looking at research data management more general, but we did get some interesting results specifically about data sharing and reproducibility, which is kind of the results I'm going to focus on. So we discovered that students are mainly sharing graphs, visualizations, or documented workflows. A few mentioned a willingness to share data that is available other places, and they felt more free to describe sources and access as opposed to sharing the unique data that they collected. And they're also more willing to kind of share, how they accessed it. Okay, I went to this website, or I found it on this portal, rather than directly passing around sort of, files that they are storing on their machines to another researcher, another student. Some reasons for a lack of, the other thing I wanted to say about this is that almost nobody had actually shared a full data set. So they're sharing plots, they're sharing workflows, but they really did not seem to be sharing data sets in any meaningful way. Some of the reasons that they were doing this is because they didn't feel confident in the hygiene or the cleanliness or the reuse value of their data. A lot of them sort of mentioned how they were waiting to see if there was a demonstrated use or a demonstrated value for their data. So despite this reluctance or unfamiliarity with actually sharing data, many of graduate students felt that it was important. So they thought data sharing in general, sharing data and code was important for reproducibility and would improve their own research area more generally. Some specific motivations that they cite include that they think is important is getting information to practitioners, discovering unintended uses of their data, which they would be excited about, increasing the credibility and reputation of a research group, and their own experience as a reader, not having enough information to understand the results presented in a published paper. So this student I really like summed up the need to kind of share information beyond just text and equations in a publication. It's really difficult to really understand exactly what's happening in an analysis or in a study by just reading a paper. And so moving on to reproducibility, the interview did not directly ask students about their understanding of or their skills in reproducible research specifically. However, nearly half of students sort of brought it up organically on their own. They identified it as an important concept. They reported difficulty in fully understanding a particular method, analysis, or data set from a publication alone. Reproducible data outputs are particularly useful to graduate students, we think, because publications are often lacking sufficient information to reapply a study or a method in a new context. And that's a really common strategy for graduate student research. So it's a really standard way to learn about methods to reapply a study that they found interesting with new data or in a different context. Okay, so some bigger themes that we pulled out when we were looking at a few of these results. A few students hadn't really gotten far enough in their research to think about the logistics of sharing data, but for others, there is a real tension between the need to publish and then the motivation to share, which really kind of prevented early sharing of data and code. So, this student mentions, if they're working on a paper about something, they would probably wait for the paper to be published before releasing the data. But then in general, the more people sharing data, the better. So I think, I was thinking about this in Mandy's presentation earlier, because really requiring the full sort of research object, including all of the reproducible data and code, along with the paper that you're submitting, could be a good way to start to resolve some of these tensions a little bit. It's not really an either or publish, which am I going to publish first? It becomes more of a like, here is my full total research project. I'm publishing the entire thing. Sharing data and code is a lot of work. It takes work beyond what has been expected from researchers in the past. And I think graduate students are really picking up on this. Even for folks who think that sharing is really critical for science and reproducibility, including this person who really considers themselves a reproducibility evangelist, finds it hard to devote energy to regularly documenting their work, which I think we can all sympathize with. Another interesting theme that continuously popped up is that the term reproducibility is largely used by students to refer to a much more general spectrum of computationally reusable data outputs. So a data package might be, more or less reproducible depending on the ability of a reuser to reproduce the results from a paper, apply a computational method in a new context or with new data, reuse parts of code, or sufficiently understand and replicate or recreate all steps of a processing pipeline. Reproducibility for civil and environmental engineering students appears to be very closely tied to whether a specific model can be applied using different data. I think this kind of discovery really dovetailed nicely with the keynote earlier today that emphasized moving away from R words like reproducibility towards T words like transparency. It seemed that kind of throughout, these students were really looking for good documentation on parameters for models, understandable code that can be reused, and very complete descriptions of inputs and workflows and processing pipelines. And focusing on concepts like transparency could help with more than kind of a fully reproducible research packet might actually be for a lot of people that will reuse data and code. The use of secondary data also really clearly affected students' attitudes towards reproducibility. So here you can see that a significant majority of interviewed students reported using at least some amount of secondary data obtained from colleagues, open data repositories or websites, or licensed from a third-party vendor. Several interviews explicitly cite the difficulty in using secondary data as a primary influencing factor in valuing reproducibility. Data that are difficult to reuse or are irreproducible clearly, affect students' perception of data quality and the importance of reproducibility. So messy, obscure, poor quality data products are difficult to use in very obvious ways, but even really high quality and reproducible data sets may be insufficient for specific reuse applications due to scale, precision, format, or other fundamental data set property. We saw a lot of students learning that not all data is suitable for every type of reuse or can be reusable without a fair amount of documentation. So we saw a lot of frustration, students not necessarily thinking that, someone was engaging in research malpractice or anything like that if they couldn't reproduce results, but really learning about how there's a lot of elements that go into trying to replicate someone's results or trying to reapply a study. So that was kind of interesting to witness. And so there were a few things that I want to bring up that we expected to find out about or expected to hear a little bit about, but we actually didn't. So we didn't ask about any of these things directly. So we're not really reporting on them. They're not results, so to speak. But I wanted to share them because I think they're interesting in a few different ways. And so one thing that we didn't hear about at all was there's no mention of funder requirements. So even in the part of the interview where we asked about data management planning, not a single student brought up funder requirements for creating a data management plan or a data sharing plan or needing to be compliant for a grant in any way. And this is especially interesting because they did bring up journal requirements, which may suggest that graduate students are, probably understandably, a lot more concerned with publishing than they are with pursuing and writing grants. So that can be useful to keep in mind, I think, when working with graduate students, particularly. Funder requirements and compliance issues, in that regard might not be a carrot, or I guess a stick, in the way that we think it might. There was also no mention of advisors or PIs playing any kind of role in teaching students about data sharing or reproducibility. We did ask in general about lab culture, sort of whether it was collaborative or independent, and how they learned about data management, either formally or informally, from their advisors or from their lab or from a course. And the results in that regard were definitely mixed. So they did find out about other data management concepts from advisors. But we were, again, a little surprised to not have the advisors show up at all in discussions about data sharing and reproducibility. There didn't seem to be, any general lab culture about, oh yeah, well, when we finish, we, post all of our data here, or we make sure that, here are the programs that we use to sort of make sure that things are reproducible or anything like that. And again, we didn't ask about them, so take everything with a grain of salt, but they did kind of stand out to us that they didn't show up. So a few things just to kind of wrap up, conclusions, recommendations, further research. This is kind of a, in process study. So you're getting the first results coming out. We are in the process of writing a paper. So hopefully, we'll have a little bit more recommendations coming out in the next few months. But in general, with regards to data sharing and reproducibility, we think that reproducibility specific training might be a pretty high value gap in education and the formal civil and environmental engineering curricula. While students did express frustration at using other people's data, that might actually not be a bad thing. Working with messy data is inevitable, whether you pursue industry or stay in academia, or change jobs completely. If you're working with data in any capacity, it is, a near certainty that your data will be crummy at some point. And so I think librarians and other research support groups can really capitalize on this frustration and hopefully identify some strategies for teaching students how to share data responsibly and openly. Some further research that I think would be interesting. Of course, I'd love to see if this can be applied to other disciplines. I'd like to see if there's some additional maybe methodologies that graduate students are using in other disciplines, or specifically lab cultures or department cultures that might really affect how data sharing and reproducibility is understood at the graduate student level. I also think it would be really interesting to compare some of these qualitative results to, formal curricula and library instruction data. So seeing kind of if the gaps that you see in the qualitative results are really mirroring the gaps that are being identified in other instruction areas. And then it's a little hard to do this still, but you could also quantitatively measure the data sharing practices of grad students and engineers, kind of more generally trying to see where they're publishing data. If it's all just being thrown on GitHub and then being forgotten about after they graduate, that could be some interesting results to look at also. So that was kind of just a quick and easy little some thoughts about some grad student interviews that we did over the summer of 2019. This is the rest of the project team. This is my email, so obviously feel free to reach out if you have done a similar study or a similar survey or interviews. We would love to hear about that too, if you could point us in that direction. But yeah, otherwise, happy to answer any questions.
Thank you so much. This was really interesting. It's really interesting because, graduate students are in a sense like our primary users, right? In the development for data repositories. So of course we want to kind of tailor different things to them. So this was really interesting to see, and these quotes were very funny.
I know, some of the quotes are really good.
So for example, I see we already have one question here in Q&A, but maybe one quick question. So these students that you interviewed, did you ask them if they had some prior coding training? Because my experience is if they had some prior coding training, then they're feeling a little bit more confident to share their code rather than, and methods, rather than if they hadn't, then they're like, oh my God, I don't want to share my spaghetti code. So does that make sense? Again.
Yeah, we didn't ask if they had had any previous experience. And since we didn't see any formal data sharing at all occurring, I don't think it really mattered really if they felt like they were more confident or not confident. I think we saw a couple people that had shared data in the context of an internship, but no one had explicitly kind of published a data set with code in a reproducible way at all. So maybe I think it would be interesting to ask that question to see if it did track with, more informal ways of sharing. So, if they're working openly on GitHub or something like that, that could be interesting. But as far as like formally publishing something in a data repository, we didn't see a lot of that happening yet. And, they're early in their careers, obviously, so we didn't expect to see that they had, but we were really looking more towards like, is this something that you value in general? And regardless of, their, experience sharing a data set or not, it was pretty uniformly valued pretty highly.
Great. So one question from the chat is, do you have any suggestions for grad students about sharing their work?
Yeah, I think it depends on your discipline and your community of researchers that you're working within. I think it's really important to follow trends that that you see happening in your, either very small community or much larger kind of broader discipline. It's hard to give general advice, but I think it's a really good first step is to see what colleagues are doing. If you have anybody that you look up to, trying to find out what they're doing. If you can find someone that's in your field that does share data, reaching out to them to see what specifically has been helpful or a good idea can be really useful. And then even though we didn't see any graduate students talking about funders, I think looking at potential funders or groups that are already funding your work can be really, have a lot of really valuable resources on things that work well. Like if you're funded by NIH, they have a really, a wealth of information on data sharing. And so looking for resources like that can be helpful.
So here, okay, so we have from Q&A, we have two questions. And the first one is, I think, more of a comment. So the anonymous attendee says that students comment about seeing the hidden code enriches the understanding of the complexity of the paper. One of the initial thoughts, though, is to be sensitive to using the term hidden in this context and perhaps use another word because it might seize upon that word to attack the credibility of someone's research.
Yeah, I think that's a good point to bring up. These quotes are, pretty faithful to how graduate students understand things. So that can be really, I think the quotes will be the most valuable part of this research project because you can really get a sense for what language they use to describe concepts like data sharing and reproducibility and some assumptions that they might be making or unintended thoughts that they might be getting across, and then tailoring both instruction and communication and outreach to address some of those issues would probably be a really good idea.
And one more question, and maybe, this one is just like maybe a question for in a minute. So did any responders indicate that their data becomes part of the larger lab group's data? Because some students at their institute have not taught much about the data archive aspect because they see it as the PI's responsibility. So I think this is a good question.
Yeah, that is a good question. Short answer is yes. Definitely it becomes part of the, we got two answers. One was, I don't know, it's the PI's responsibility. It's the lab's data when I leave, so they can decide what they want to do with it. And I have no idea what's going to happen to my data when I graduate. So I think we saw a lot of, in some of the other more like active data management parts of the interview, we saw a lot more students, you know, talking about, yes, well, I got this inherited data from someone that I was working with, but then they graduated and I'm using a part of their data, or we have a lab hard drive that has all these different, you know, experiments on it that we collected data from. And so I think that is a really common scenario, and that definitely comes up more related to lab culture and kind of active data management during the active phase of a project.
Thank you. That was great.